Hi, everyone. So my talk is about blockchain. I think Riga Dev Days couldn't have happened without at least one or two blockchain talks, now that it's such a buzzword. It's called DApps and the Decentralized Web. Maybe you have heard of the term DApps, maybe not. Also remember the subtitle, The Journey to Web3. It's quite important at the end. My name is Amaury. I work at Parity Technologies here, which is a core blockchain technology, core technology startup. I'm also a member of the TopTal freelancing community, TopTal, which is a sponsor today at this event. At Parity, I built DApps, whatever it means for now. I built JavaScript libraries for web developers because I come from a full-stack web development background. And I also built some UI stuff on my free time. So I would like to start by covering some headlines over the past years that I found on the internet. Let's go. Let's start with this one. I suppose you all know what it's referring to. Yeah, I see some people nodding. Snowden, NSA leaks about the government tapping our conversation via microphone, webcam. Some companies are also helping them. Next one. So this is a big one. This is I really like this one. Equifax, the credit agency, got hacked. 143 million of people, of consumers, had their data hacked, which is like 40% of the US population. So this one's pretty big. Next one. I guess you all know what this is about. Cambridge Analytica. This is quite recent. Yeah, so what do I want to show you with all these headlines? So my point is that we have built some tools over the past 30 years, let's say. We have built tools on the internet. And today we use these tools extensively. For example, like think about trying to buy a train ticket without using your computer or without anyone in the chain using your computer. It's almost impossible. Small stuff like that, it's impossible to do without computer, sending a message to a friend. So we have built tools, and all these tools that we have built are 100% based on the trust and the faith we have put into the people who have built these tools. But sometimes these people have made broken tools. Their tools are broken, sometimes even deliberately. So it's kind of a tricky situation. Let me put this slide, which you should be all aware of already. The Web 2.0, the client-server architecture, what I call the Web 2.0. So basically, it's the service provider model, what I call the service provider. There's them, the service providers, Facebook, Twitter, Netflix, Google, whatever, and us, the user. So what do we have? What do they have? We have an interface. We have maybe the websites on our browser, or maybe the nice interface in a mobile app. And what do they have? They have a server, or like it's mostly an entity controlling a lot of servers, which will host all the static files, all the images, all the text, which will hold all our communication. Facebook Messenger, I send a message. The message is stored on their servers. They hold our user credentials. So that's a big one. That's why those Equifax got hacked. And also they host the data logic. So they manage how everything is worked. So this is the Web 2.0 architecture. And why is this broken? Or maybe not broken, but there's some places where I feel it's not natural. For example, let's say I'm here in this room and I want to send a message to my friend, which is right next to me. I send a message on Messenger. This message goes to whatever that data center. It goes to Mark Zuckerberg's company, and then back to this person, which was right next to me. It does this round trip, which is kind of like if you take a little bit step back and think about it. It's not necessary to do a round trip if you have architected since the beginning a better model. Another use case I'm thinking of is like imagine a little town that gets internet within, but cut out of the rest of the world. Imagine some countries. They should still be able to use Facebook Messenger or like these similar services internally without any communication outside, but internally. So yeah, that's the point I don't like about this this model. And also, one more thing I want to add. So like basically our data are stored on the servers, and these data, they get bigger and bigger. Like Facebook, they have tons of data. And it's kind of like creating some clusters on the internet of big superpowers having a lot of our data. And kind of creates a data kind of slavery or data monarchy where we are really slave about what they do with our data. We don't have control, and they can do whatever they want unless they tell us not to. So to solve this kind of data slavery and data monarchy kind of situation, there's one way of stabilizing it. It's dilution, to put this power, to put the data a bit more spread out, a bit more decentralized. That's why it's called the decentralized web. And instead of creating a data monarchy, would create a data democracy where, data is a bit everywhere. So having said that, let's see chapter 2, what is Web3? Before I was talking about the Web 2.0, now I'm going to transition to Web 3. So first, a quick note. The Web 3 I'm talking about is not the semantic web. Like it was a thing maybe 5 years ago, something like that. Today I don't hear much about it. I don't know if it's still really popular or not. The Web 3 I'm talking about is not at all this Web 3. It's another direction the web could go. And I want to show you what that direction is. First of all, Web3 is an extensible framework for creating massively multi-user, economically strong applications. Extensible framework. It's a software framework. So people write software with Web3, and these software can communicate with other softwares that are written with Web3, and just creates a kind of ecosystem around this. Creating massively multi-user. Massively multi-user, we're talking about 10 million, 100 million, maybe 1 or 2 billion. This scale of users. That's the aim of Web3. And economically strong applications. What do I mean by that? It's basically where you trust the framework to make the economic decisions that you want to do. Typically, think about Facebook. They introduced some payments. You wouldn't trust Facebook so much to do a payment of $10,000, $100,000 or something like that. With Web3, with the blockchain, what Web3 wants to create is really like a framework where this should be without any problem, like whatever the amount it is. That's what I mean by economically strong. Second thing about Web3, it tries to blur the line between service providers and users. So, think about the Web 2.0 model. There was us vs them, service providers, users, and generally the users pay a little bit of stuff, and the service provider provides the service in return. So it's kind of this type of hierarchy. With Web3, there's no difference between a service provider and a user. These two are nodes, two nodes on the network with the same amount of rights and the same amount of rights. Some of them might do a bit more of service providing. Some of them are more using the service. But ultimately, they have the same, they can be interchangeable. This is what Web3 tries to achieve. One example that you might have used is BitTorrent, where basically you are at the same time a service provider because you're hosting the file and giving, seeding the file for other people. And at the same time, you're a user because you're downloading the whatever movie illegally that you're downloading. So this type of, it blurs the line. You're both at the same time. Another example I can think of is the energy sector, where today, you might have this big energy company in your country that is selling electricity to everyone and everyone's buying. But imagine an energy sector built on Web3. It would be every people who wanted to sell their energy with their solar energy or whatever kind of energy. They would not sell it to that big company, which is the case today, but they could sell it to their neighbor or anyone who wants it. So there's no central entity that's controlling the buying and selling of everything. So this is the second thing Web3 tries to solve. And now we're going to the third part. Web3 is a new way of architecting web applications. So this is going to be the bulk of my talk. And I will really insist on this. So how today, because we're all like related more or less to web, how today we can use Web3 to start creating web applications which follow the previous rules. So remember that diagram on the top right? It was the Web 2.0 architecture. Let's see Web3 architecture for a website. What does it mean? We still have the user device. And I like to put the user device in the middle because it's kind of the most important stuff. So the user device still holds the interface, either the mobile interface or the web HTML files. It also holds another thing. It also holds the user credentials. So this is super important because the credentials are always stored locally, and you will send the necessary data via permissions to the websites that request those permissions. So you manage those permissions, and the user credentials never get away from your local computer. And that's super interesting because this would typically avoid, a massive hack of 143 million user credentials got hacked. This type of situation, if you store them locally, it will totally solve that. So this user device, the client, will communicate with different parts. First of all, we'll communicate with the blockchain here on the right. The blockchain we'll have two rows. The first row will be the database. So the data will be stored on the blockchain. And the second row is the data logic. So everything that's computing, everything that's generating some all the backend stuff will be put on the blockchain. On the other side, for communication, if I want to send a message to my friend, it will be done with a protocol called Whisper, which is super new. It's really under development right now. But the concept is really here. So basically, it's a peer-to-peer messaging protocol. Same thing for the static files. Instead of hosting your files on the central server on Amazon S3 or whatever, you would host on something called Swarm. Or there's another parallel project called IPFS, which we will see later on. So basically, these are service like protocols which enable you to store files distributively on like a distributed file system. So these are the main components today that we have in the blockchain ecosystem to build a Web3 application, an application built on Web3. Still, like the user device is in the middle, and it communicates and it glues different parts of the ecosystem. Here is on an EC2 on Amazon or Google Cloud Platform, and I will code my API on this backend server. With Web3, you would code the same API, the same functions, on something called smart contracts, which are programs that are running on the blockchain. And we will have a really concrete example right after. Second of all, the database, the storage. I mean, like right now it's on database on some other server. Local store or something on the local storage on the front. Like by local storage, I mean all the kind of front-end storage like IndexedDB, session storage. With Web3, you would store the data, as I said before, on the blockchain. And for the front end, you would still use local storage. The presentation part, the client part doesn't change. You still use the same technologies, HTML, JavaScript, to create presentation. Next part, the hosting, the static files hosting. Right now on S3, on Google Cloud Storage, on your own server, but you have a centralized server which stores all the static files. And in the Web3, you would have IPFS or Swarm, which are two of the most popular protocols right now to do static files hosting. And finally, dynamic updates. For example, if I send a message, I want the message to be instantly on my friend's phone. Right now, it's done either with HTTP polling or WebSockets. With Web3, there's this protocol called Whisper, which I explained, which is totally peer-to-peer. So here's the overview. It's really theoretical for now, but since we're all developers here, I want to add, a DApp is a web app that runs on a Web3 architecture. So since we're all developers here, I will show you really how a DApp will work, and we will build a DApp. I want to add something that you might not like. It's serverless, but not in the term of Amazon Lambda or something else, or Google Cloud Functions, for example. It's really serverless in the meaning that there's no even a central entity controlling the containers or whatever you spawn. It's serverless, meaning that there's no backend, there's no one, there's only the network. So if you send something, you send to the network, and the network will somehow give you a response. So that it's truly serverless. So chapter 3, let's get into the code. Probably the most interesting part for someone. So before what I said, it was really theoretical. You might have some idea, but maybe not so clear, or I don't know. Now I will really go through all the parts one by one and make a demo of a decentralized block that we'll try to build together. So I'll go back to this presentation, like summary table. We will use smart contracts in our demo to do the data logic. We will use the blockchain. We will store our blog post on the blockchain. We will use some presentation, some really easy presentation to show the blocks. And we will host our images on IPFS. So I will use these 4 technologies. And one by one, first of all, I will explain in detail what they do. And then I will show a demo each time using each of them of the technology. And at the end, we'll have a small demo of our working decentralized block. First of all, the blockchain. Remember, it was the storage part, the database, the equivalent of the database. So the blockchain, there are a lot of blockchains which allow a Web3, a Web3 ecosystem. One of them is Ethereum. There are a couple of others. If you want to know like the difference between the different blockchains, just chat me up right after the talk. I'll be happy to discuss about it. So I'm really into Ethereum. My work is about Ethereum, so I will really explain Ethereum. So in Ethereum, the database, it's also called the state, actually mostly called the state, is basically a key value mapping. At its most simple form, it's account A has 3 Ether, account B has 5 Ether. It's really like a simple key value mapping like that. And it's you can see that this key value mapping as a state machine. So you can modify the state, and you modify the state by calling a transaction. A transaction is something that you send to the network. For example, you send account A gives 5 Ether to account B. So this is a transaction, and the states will modify accordingly to what you have sent in the transactions. So transactions cost money. You need some money to run a transaction because you are modifying the state. It costs some money. Second of all, what you can do on the state is read the state, obviously. You just make a call to the network. You say, I want to read this particular account, the balance of this account. And to read the state, it's completely free. So how does it work? So each node, remember, there's no server and client. Everybody's a node. Each node, each blue point here, will have a full copy of the entire blockchain. So since block 0 until block 2 it will have all the transactions. The blockchain contains all the transactions. So each node will download these, it's about 20 gigabytes of transactions, and will apply, at the beginning was empty state, will apply each transaction one by one until today's block. So each node will have, since it's the same blockchain for everyone, each node will have the same state today with all the balances, with all the accounts. There are, so these all these state, how we modify states, what port we're listening to, etc. All these are in a spec, in a specification file by an organization called the Ethereum Foundation, written in the yellow paper since the beginning. So there are a lot of implementation. They just follow this yellow paper or white paper, and they follow exactly this, and they build their implementation in their own language. So I work at Parity, which does one of the implementation written in Rust. If you want to try Parity, it's pretty simple. Just go to parity.io. You'll be invited to this page. Download Parity. I will show you a quick demo of what you have when you download. So I'll close this. So when you download, you have a command line interface with a parity command. So I can type help, and you'll see like a bunch of commands to, a bunch of flags to configure your node. Basically, how many peers you want to listen to, if you want to use full capacity, not so much capacity, etc. I will just show one flag because I'll use it. It's the chain flag. Basically, with the chain flag, you can decide to connect either to the main Ethereum network or to a test net or to other, local networks that you create. For example, companies, they create like private networks. So you can connect to any chain. Here today, I will connect to the dev chain. The dev chain is it's basically a chain where there's only me actually. So it's a local environment used for dev. So when it started, it show you some info about its configuration. So on this network, I'm the only one, and it's only for dev. And you'll be also invited to this Parity. It's called Parity UI. This user interface. If you don't like a command line interface. So basically, this is a simple interface where you can see your account. Here I have 2 accounts. You can see your accounts. About the accounts. So all these information are stored locally on your local Parity node, and that's the part where it's stored locally. You can change accounts, and here everything you see here, each one of these little squares is a DApp. So it's an app that connects to the blockchain to do a simple service. For example, this browse DApps, it's basically a DApp store where you can just have a look and download like any DApp that you want. So here there are not a lot of DApps because I'm on the dev chain, so on my chain, so there are only these DApps. But on the main Ethereum network, there are a lot of DApps that you can try and install. Some of them are doing weird stuff, but some of them are quite interesting. What's interesting about this? It's like this DApp store is coded by Parity, but the thing, it's not controlled anymore by Parity because it's decentralized. It's it's run on every node, so Parity cannot even modify the code. It's totally decentralized, totally uncensored, which has its pros and cons, obviously. But right now, it's totally uncensored, and anybody can push a DApp to the DApp store, available for anybody else who uses this Ethereum. So DB here, this is the interesting one. It's not Deutsche Bahn, it might look like. It's a decentralized block, so it's our block. I will show you. So I have 2. This one is the one we're going to build. This one is a demo. So I will just show a demo just for you to have an idea what we have. So we are invited into this presentation page. On the home, we have all the blog posts. This is the first blog post of the D blog, second post. If I click on a blog post, I will have the title, the author, which is a public address. We don't put names. A small content of the blog post, and an image. Same for the second post. An Egyptian painting for the second post. So with this blog, this is the homepage. I can write a new post, or I can look at my account where I will see that my Ethereum address is this, and my IPFS, the one used for static file hosting, is this. So this is really a simple DApp that we're gonna build, but it's actually complicated enough to do what we would do in a simple web application out there. There are calls, API calls. There's some account management, etc., etc. So this is what we're going to build. Let me get back to my slides. Optional mining. You might have heard of the mining. So each node, when you download a Parity node, you have the full state on your local computer. One thing you could do additionally is called mining. It's basically using your hash power of your computer to solve like a complicated puzzle. But you would do this because in return you can earn free ether. And that's how the network is incentivized, because every 15 seconds there's like 5 ether which is given randomly to someone who found the puzzle. And that's why more people are trying to download a client and try to mine, trying to earn these ethers. And at the same time, by using this calculation power, they are making the network safe. So I won't go into details about this because it's more about blockchain and not about Ethereum. But it's interesting. It's optional, and we won't use it today. First part was database. Second part, the data logic. Smart contracts. Smart contracts, as I said before, were programs run on the blockchain. What does it mean? So remember, like transaction, I can send 3 Ether from A to B, but I can also send 3 Ether from A to B with some payload, with a message. Or as a matter of fact, 0 Ether from A to B with a payload. And the payload, interestingly enough, in Ethereum, it contains some operations, some bytecode operations. So it's really, there are about 130 opcodes. So you just, put a long string of these opcodes, and these opcodes create a small program. And there's something called the Ethereum virtual machine who will understand these opcodes, who are like in every node. So they will see a transaction with a payload, they will see the bytecode, execute the bytecode will modify the local states, and this is how we have a program. And these bytecode creates a Turing complete language, so there's a lot of stuff that we can do with this smart contracts. So how can we create programs then? So here, each program will have its own public address, exactly the same as a regular account, which will have its own public address and a balance. Here, 0123, 123 has 4.3 Ether. It's its balance. Contract will be 0x456, but instead of having just a simple balance, it would have some states. You'll have a variable A, variable B, variable C, whatever variables you define in your contract. So each contract has its own state. And if you send a transaction to this contract with the correct bytecode that will modify the correct variable, you can have persistent states inside the blockchain, inside your own program. And if you define some more complicated functions inside the smart contracts, well, you can create very, very complicated applications totally based on the Ethereum blockchain. So basically, if I send a transaction to a contract, it basically means I'm running a function on this contract. I'm doing something on this contract. So let's see the smart contracts part in our block. Perfect. So here I'm defining. So here's the language and the version of Solidity. Solidity is a high-level language, quite similar to JavaScript, which compiles directly into a bytecode, which can be read by the Ethereum virtual machine. So at the most simple, for me, a contract blog, a blog program, is something that has a post, and a post is an author, a body, an image, and a title. So the image is actually not the full image, but the hash of the image. We'll see that in detail later. So I create in my contract a mapping between actually the ID and the post. So a key value, the key is the ID of the post, and the value is the whole post. It's called post map. I create also a list of all posts ID. I put in an array for a simple, for simple simplicity's sake. And it's basically, remember on the homepage where we had the list of our blogs, basically we'll use the post IDs. There's something called an event in Solidity, which is really an event that you can emit anytime you want. And if any frontend is listening to the event, they will receive in real time this event. So here, every time I create a new post, I will emit this event, and if any frontend is listening, they will know in real time that the event has been created. You can use a constructor. It's a classical behavior. So let's see our create post function. Takes a body, an image, and a title. First of all, we do some checks before creating any post. We don't accept empty bodies. We want the body length to have a good length. The ID. How do we generate the ID of a blog post? I could have used a random number. It's not so good. I have used here the SHA-3, which is a hash function. SHA-3 of the body. So basically, each body will generate a unique ID. And the next thing is that we cannot have two blog posts with the same body because they would have the same ID, and it'll create a conflict. So that's what I'm verifying here. If all these checks have passed, then I will create a new post with the author being the one who sent the transaction. That's why it's not in the arguments. So the one who sent the transaction will be the author. The body will be the body, image, title, and then I'll just push in my array and put it in my mapping. So pretty simple stuff. And at the end, I emit my event so that if anybody's listening, they will have in real time. So this was the create post. Next one, get post. Oh, by the way, like if you look at this, it's really like a crude create, read, update, delete. There's no update and delete here. But it's really like, more or less following the same pattern. So each contract will do one, will take care of one entity. And for all the operations we can do on this entity. Next one, get post, takes as an input the ID and returns author, body, image, and title. Simple enough. We just put the return values that we take from our mapping, from our initial mapping. And next one, get summaries. It's basically a bit like a custom function where I parse through all the post IDs and I fetch the title so that on my homepage I can get all the titles of my blog post. So this is our blog. So if I go back to my UI, there's this little tab called Develop Contracts where I can actually develop contracts inside. So I can copy the code. I already put here. So it's exactly the same code here. I can compile it. It's auto-compiling. You will see here the bytecode, the exact bytecode that will be generated from the Solidity. So this will be in the transaction payload, some metadata also. ABI, it's quite technical. I won't go into the details, but you can deploy. So I will deploy and I will put a name for my contract, dblog1. Just dblog. Create. So when I create, it will tell me. So this is like a confirmation. It will tell me that with this account, which has a lot of ether, but it's only on my dev chain, so it doesn't count. We'll deploy a contract. Will cost this amount of gas, which is like a sub nomination of ether. So it doesn't cost a lot. Anyway, I have a lot. I'll put my password. I confirm the request, and it will say that my transaction has been mined. So on the dev chain, on the local chain, everything is instantly mined so that there's no waiting. So I can see my blog post here. If I click on it, I can see my get summaries, get post, post my, all the things I define in my contract, they're here. This is really like a simple interface to communicate with the contract, with any kind of contract. I can also execute the create post. So let me execute. So this is written from UI. Image, I won't put something. Title is in hex, so I need to put something here. Post transactions will execute the create post function to this contract. Very cool. I confirm this. And then I see that get summaries has something. I see the new event that has been emitted. If I copy the ID of the post, I put it here and I query it, I see that it's what I've written. So now this small part is already in the blockchain. It's totally in the blockchain. So this is how you create a contract and basically communicate with the contract. Next step, the hosting, IPFS. So IPFS, it's a project which aims to create a distributed file system. Basically, your content, if you add to IPFS, your content will be stored on a lot of nodes. The number of nodes depends on how much you pay. If you pay more, of course, it will be replicated more often. And so this will take care of moving the files, etc., etc. Second of all, it fetches the content by hash. So instead of having a location for each of your file, you calculate a unique hash of your file, and you ask the network, the IPFS network, so who has this file with this particular hash? And a node will reply to you. So concretely, how does it look like? A very quick demo. I'll clear this. So I run IPFS add, and I just put some image that I have. So it was in Riga days, Egyptian painting. And it will say added. This is the hash of my Egyptian painting, and this is the name. But we don't care about the name because it's the hash that's super important. If I copy it, and if I go to all right, it's already here. So what I have here, it's basically the same hash that I here. I can copy it again. It's the same hash. So it will go ask the network who has this hash, and it will return to me exactly the file. So I don't know which node returned to me this one, probably mine. because I have it on my local computer. But any node could host this file, and any node could use it. That was IPFS. And finally, putting all the things together, the front end, the presentation part, the JavaScript part. So you know how like front end has gained like more importance since like 10 years or something like that. Before it was only animations, and now it's whole applications built on JavaScript. With Web3, it's going the same direction. It's really the front end's job to glue everything together. So to fetch the data from the blockchain, to fetch the images from IPFS, to communicate with Whisper. It's the front end that manages all that. So basically, we'll call the get summaries, get posts. I'll quickly show some examples. For example, let's say create post. This is a simple React app. For the create post, I have a form which will submit something. And when I submit, I will just call my contract. I will define a contract with some JavaScript APIs libraries. I will define a contract with a correct address, etc. And I will call the create post. I will post a transaction with my body, image hash, title, image hash being the one generated by IPFS. And then I'll just wait for it to resolve, and I'll have my my blog post created. So let's see that. First of all, I would need to go back to our D blog because a unique account address has been generated for the D blog we just created. I'll copy that. I'll put it in my api.js, where here I define the new contract. So I'm using these libraries to abstract all this stuff. It's not really important. The important part is that I create a contract. I put the exact address that I'm having. I'm saving, going back to my decentralized blog. And if I have look here, so ABC was the one I actually created before with the other, not so pretty interface. If I click on it, remember this was written from the UI. The author is exactly my current author, EA72. And I can see my account. I can write a new post. So write a new post is exactly the code we just seen before with the create post function. If I put a title, second post, some random text, I can upload a file. I'll upload the same Egyptian painting. So when I upload it, they say you can see your file here. I can open it and see it here again, the pretty Egyptian printing. I can submit. We'll execute the create post on this dblog contract. Very cool. Confirm request. And if I go back to my homepage, I'll have the second post, which I just created. So let's stop here for like 1 minute and think about where all the data is stored. So this author and random text is stored on the blockchain, not on a central server anywhere. It's stored on the blockchain. This image is stored on IPFS, and the image hash is also stored on the blockchain. So here we have created a really simple app. It's really simple, but everything is decentralized. Nothing is controlled by anybody. This DApp, this decentralized blog, if I publish it tomorrow to the DApp store, everybody can use it. Everybody can create an account and post it, and nobody can control it anymore. It's on the blockchain. It'll be there forever, and nobody can change it. So it's not controlled by anybody. Let me go back to my slides. Today and tomorrow, what I want to talk about here is where we're at in the Ethereum community today, and tomorrow what are our plans. So Ethereum is still at its beginning. It's facing a lot of problems. The first one is scalability. Does anybody know this logo? Exactly, CryptoKitties. It's like a stupid you can exchange cat cards. And you can make cats breed together to create special cats, whatever. It got super popular. It got really popular. Like in the Ethereum world, it got really popular. It was like 15,000 users. That's popular in the Ethereum community today. 15,000 users, this clogged the entire network. It was impossible to send a regular transaction to my friend when there was a CryptoKitties events going on. So scalability is a big issue. Second of all, high prices. It costs money. It costs money to store and to execute stuff on a smart contract. Our blog posts will never survive on the main Ethereum network. There's too much data to be stored. too much execution. Even like a simple one, it will cost a lot of money. So it's not a good idea. Asynchronous, it takes 1 minute. Like here it was instant, to confirm my transaction. On the main Ethereum network, it takes a bit more than 1 minute to confirm a transaction. Maybe not the best UX. There are high barriers to entry, public address, private key, gas, ether, whatever. All those technical terms for regular user, it's too much. Everything is public. Our blog post is on the blockchain, on a public blockchain, so everybody can see the content. It has its pros and cons. We'll see in the future. And also doesn't mesh today really easily with the real world. Well, that's particular to Ethereum. Some other are better. But for example, if you want to generate a random number on Ethereum or, fetch a weather API via a smart contract, it's pretty hard to do today. So that's kind of problems. But my point is that actually those are more like implementation details. Like maybe hard ones, for example, scalability or high prices. There's some game theory going on behind to find the right amount of incentivization to keep the prices at the correct level. But like I believe that ultimately someone will find a perfect blockchain. Maybe it's Ethereum, maybe it's another one, maybe it will be created in 10 years, which will have the right parameters, the right amount of everything, so that it could make Web3 work. Because I believe that today the concept of Web3 is here. So actually yesterday someone asked me, so what's the use case of any blockchain? I'm like, today there's no real use case. I'm sorry about that. But the thing is, the concept is here, and I really love this concept of having a web application that can ride on a totally decentralized framework where no central entity will have your data, and there'll be never any hacks like the Equifax one because no one will hold so much data at the same time. So what I've talked about, the data, the democracy, the dilution of data. So for me, it's a beautiful concept, and I really want to see Web3 develop in this direction. I could have ended my talk here, but I actually want to end on a call to action for you. The journey to Web3. Sorry, I told you to remember this subtitle. Today we are on the left here, totally centralized, where you have these big corporations holding a lot of data. What I described in this presentation is the ideal world of Web3. Totally not the case today. But there's a gray area where little steps can be made. And my call to action is basically for you to make these little steps, to have a look at Web3, Web3.js, Web3, everything around Web3 on the internet. Maybe if it's relevant to your, to your use case, maybe code something, a part of your application, a microservice, contacting with the Ethereum blockchain. Maybe host your images on IPFS. Maybe just give it a try. And I think it's these little steps that will help develop the Ethereum community and the Web3 framework. So thank you. My email is here. My social media handle, Twitter, Reddit, GitHub is here. For the resources, if you like the D-blog, if you like the name, if you like whatever, it's on GitHub, totally open source. If you want to get started with Web3 or with Parity in particular, you can go to our wiki, which is pretty detailed and has really simple steps on how to get started. And thank you.
Thank you very much. It's time for questions. Anyone?
So the code that we see in the smart contract,
yes.
Where does the code execute? Does it execute on the peers or at the function level where does a function get deserialized and go and execute on the peers, or it will execute on the some centralized server?
No. It's so basically the code. You remember the bytecode, all the numbers. This is included in a transaction. When you call a function on this smart contract, it's in the payload of the transaction. So every node will receive the blockchain with this transaction, and every node on the peer will see that there's some bytecode that can be executed. So every node will actually execute that code to generate their own state after this transaction.
So it will be a lot of load on the clients there will be a lot of load if the program is big, if the smart contract is big.
Exactly, and that's one of the problem of scalability is that the blockchain is getting actually quite long today, and there are a lot of transactions, a lot of code, and like small computers are starting to get, like home computers starting to get a bit not at the level to execute everything. And this is one of the problem because maybe some nodes don't need to execute all the transactions. Maybe only the powerful nodes, but define powerful. Maybe only the powerful nodes will execute the transaction. There are a lot of questions today.
And it's also the same case with the blockchain itself, right? It's like the blockchain that you have may not be the real blockchain. Real blockchain is the one which has like a lot of people who have that information.
The real blockchain is the longest blockchain. So it's basically, if you have two groups that don't communicate and they all have their own blockchains, at one point, when they communicate, the real one will be the longest one. And the other group will need to follow the first one.
Oh, is it the longest one or the more number of peers?
It's the longest one.
Is the longest one?
Yes.
Any other questions?
Do you know if there is any strategy how to overcome the difficulties with the blockchain growing very large?
Yes. There's one thing called sharding in blockchain, which is basically, right now every peer, like I explained before, every peer has the full blockchain from the block 0 to today, and every peer will execute all the transactions. Sharding, basically, the idea is to cut the blockchain into small parts. And some nodes will have this part of the blockchain, other nodes that part. And basically, if you want some data, you just ping the correct node that has the relevant part of the blockchain for you. The second solution is called everything that's called level 2. So it's level 1 is the the blockchain, and something above. For example, if you want to communicate, like do some payments with a friend, you can create a secret channel between you and your friend. Send a lot of transactions on this one, and at the end, where you are settled, it's called settlement on the blockchain. So you create a lot of transactions and you settle on the blockchain, so that there's actually only one real transactions that on the blockchain. But in the middle, you can do a lot of transactions between you and your friend. So there are some ideas of development. Yeah, it's kind of completion. It's yeah, you can say that, but it's another level, there's another level and there's a settlement at the end on the blockchain.
Okay, for last question.
As we know, contracts are immutable, but at least I do not know any business today which does not require changes. Are there any techniques to deal with it?
Yeah, of course. There's one simple technique called the proxy technique. So you create one contract, which will have one variable called real contract address, or your contract address. And in this contract, in this proxy main contract, you can just change the address, and it will execute, the real one that can be generated over and over and over again. Does it make sense?